And hello everybody, we're back for our final demo of the day. I have with me here Manuel, who's from Pixar, who's going to be taking us through some PTex technology. For those of you who don't know what PTex technology, all the more reason is to sit down and actually check out what we've got, because there's some very cool stuff here. And why don't you just take it away and show us what you got.
Thank you. So I work with Pixar in the software engineering department, and we've been big fans of Mudbox for quite a while now. And in fact, I'll start by asking a general question. Who has seen Toy Story 3 here? Yeah? Can anybody guess which one of the characters in Toy Story 3 was modeled and sculpted with Mudbox? Anyone? Any hands? Giving up? All right, I'll show it to you. So let's get started quickly. Well, as quickly as the video goes, at least. And this is the first character that Pixar has actually ever sculpted with Mudbox. So this is Chunk, is one of the evil toys in the playground. And I won't spoil the whole plot because that's not really the point of my talk, but what I wanted to talk to you tonight about is how we actually are trying to integrate Mudbox into our pipelines to actually generate very highly detailed new type of geometries that haven't been done before, at least that we haven't done before, to new levels of realisms. So let me give you some numbers first. So this guy, Chunk, by default as a Maya model, weighs about 20,000 faces. That's good enough for us that we can manipulate this interactively. We can pose him, we can animate him, but really it doesn't quite look good enough. On the other hand, his sculpture in Mudbox is about 3.1 million quads. This, on the other hand, we cannot animate. We cannot work with. It is not interactive anymore. We can't pose him. The animators can't work with that. It's just too heavy. So the question comes now for us, how are we going to render this? Whoops. And the answer over here was a combination of technologies. So the first one is obviously sculpting the asset with Mudbox, but the other one is taking the rest of that information all the way through the pipeline so that it renders as a beautiful image, just like the one that you see over here with all the shading applied on it. And that's where the PTex technology that was originally invented at Disney came in very handy. So I'll go very slowly through all these steps, and I'll try to describe all this stuff. So at Pixar, as you may or may not know, we use a piece of rendering software called Renderman. And some of the cool features that we have in Renderman and that are very useful to us is we can do vector displacements. So in other words, take the surface and displace it to any arbitrary position in space. We can also read PTex textures natively. That's not part of Renderman as version 15, so you can feed a PTex texture file to Renderman and it'll read it. And we also have a need for ambient occlusion, so I'll cover that a bit later. I'll get back to this. Let's get started with the basics. When you model in Maya, you model a polygon cage. So you got a bunch of vertices that create a polygon mesh surface. It's a hard shell, and that's the 28,000 vertices, or 28,000 faces that you saw before that we pose, animate, articulate, and work with. When it comes to rendering, however, oops, my bad. What happens in Mudbox, however, is you take that low-resolution mesh, use Shift-D, and you up-res it to a very large amount of quads, and then you sculpt it, which gives you a nearly smooth, very detailed surface as the one as you see over here. Again, I'm simplifying here just for the sake of explaining how things work. However, when it comes to render time, as far as the renderer is concerned, that original polygon mesh becomes a subdivision surface, which renders infinitely smooth. That's what we call the limit surface, because it's a mathematical formula that generates a perfectly smooth surface. That is usually what we're looking for if we're modeling things which are made by humans, sort of sharp artificial objects. In the case of organic content, however, this doesn't work quite so good. So the trick over here is that we want to use displacement maps to go from the limit surface of the subdivision, which is the basic normal Catmull-Clark surface that we have, to what we have sculpted in Mudbox. For Mudbox users, you probably start thinking, oh well, that's really easy. Piece of cake, I'm just going to go and extract a displacement map out of Mudbox using the existing features that you have seen. The catch over here is that this particular displacement happens only along the surface normals, because what you get out of the extraction is a grayscale map, right? Instead, that leaves us with a little bit of a problem, because in this particular case here, that scalar displacement cannot cover curls or cusps in geometry that is that kind of shape. So it already limits what your artists can sculpt out on Mudbox. This is not good enough. Chunk over here could not have been produced with this. Instead, what we need is 3D vectors. So the texture map, instead of just being one single grayscale value for each texel, becomes a vector texture map. Each texel is a 3-dimensional vector that tells exactly where the surface has to move. And if you look closely over here, you'll see that the vectors crisscross each other, which is absolutely really no problem when you render this stuff. So that's the basic idea. Now, I'm going to bring another concept into the mix. If you use Mudbox, you're all familiar with it. You've got this Shift-D key, right? So you take the low-resolution mesh, you keep on upresing and upresing, and every time you upres one more level, you get one more power of true resolution in the mesh. So far, so good? Well, this actually has a very good advantage for us, because that sort of gives us an implicit mapping that says, well, actually, this quad over here in the high-resolution sculpted mesh has a very logical texel position here in the coarse, low-polygon mesh. So far, so good? This, at least, is true as long as you use quads only. And I'm not really going to go into too much details just yet. I'll get back to this, but once you have meshes that have triangles, pentagons into the mix, this becomes actually horrendously more complicated. I'll get back to this in a bit. Now comes the little bit about PTex. So you're all familiar with Mudbox. When you start sculpting and you start painting, you need to unwrap a UV layout, right? Fortunately for us, Disney a couple of years ago, 3 years ago, excuse me, came up with a new technology for texturing that's called PTex. PTex stands for per face texturing, which is basically a technology that allows us to literally have texture maps that are 3-dimensional and do not require UV layouts. You do not have to unwrap UVs anymore. This is all done automatically for you. So I'll go in a little bit more detail about that. Sorry to be a bit painful, but I need to set up a little bit the stage. So perfect texturing means that each face now is associated with a unique ID in the mesh. So if you start, you get a bunch of quads in the mesh. There's quad 0, 1, 2, 3, and you keep on counting. We also keep what we call an adjacency table so that each quad knows which ones of its other faces are its neighbors. So face number 5 knows that maybe face 2, 4, 6, and 8 are its surrounding neighbors. And the final detail about PTex is when you render the texture, the renderer knows exactly how to use all this information to filter the textures and guarantee that, in turn, we have no seams, so there's no problems, there's no more need to gutter textures around where you had seams on your UV layouts, all that stuff goes away. There's no more UV layouts, and more importantly, your texture is filtered in what we call the C2 continuous manner, which means that if you use it to do displacement maps that have reflections after that, you don't have any breaks, you don't have any cracks, it all looks perfect and beautiful. That's the advantages, and that's the reason that when we looked at Chunk, we decided, well, we can't really use UV layouts. It's too tedious to unwrap all those UV layouts on all our assets. We're going to transform those textures to PTex. Now, the problem with all this is that good old Chunk over here was done in the days when Mudbox knew nothing about PTex. So the process for us became very tedious and very complicated because we had to use point clouds extraction. There's all sorts of custom software that is really complicated that you really don't want to hear about if you're an artist. It's not fun. It involves a lot of manual labor to clean up and correct problems. Not really the best solution. So now I'm going to show you the technology as it is existing today. But this is a bit unusual in the sense I'm actually going to present technology that Pixar is actually currently working on actively. This is something that is entirely new. Nobody knows about it just yet. So in a sense, you get a sort of sneak peek and glimpse into our own new technologies. And because this is currently used on assets that are involved in movies that haven't been even announced yet, I couldn't actually grab one of our production assets because I would have to jump through hoops of fire with Disney to show this to you today. So I need to thank over here Autodesk for being so gracious and lending to me one of their demo assets, which you probably have seen in the previous years, which is a Toad King, which is a great sculpture from Craig Barr, who's over there somewhere, and has beautifully and masterfully crafted this particular asset that we're using today. Also, the other thing I would like to apply over here is a quick disclaimer, because this demo was really put together last week in a lot of hurry. So all the software you're about to see is very much beta stage. It is not final. User interfaces are probably going to change by the time you see them. And what you're going to see here is by no means probably the final product. This is work in progress. but we're so excited about the technology that we're interested in sharing with everyone. So I'm going to get started over here. So the Toad King in Mudbox over here, for those who haven't seen it yet, I'm going to give you a few seconds to get familiar with the asset. This is how it looks like in Mudbox as you sculpt it. Unfortunately, once again, I had to do my capture over here on the low-powered MacBook for various technical reasons, so it doesn't have its reflection passes, but it looks pretty close to what you would see in Mudbox if you were the artist sculpting this particular asset. And I'm zooming in so you can actually see all the beautiful detail that was hand-painted and hand-sculpted, which really shows off the great qualities that we really want out of Mudbox, which is insane amount of sculpting detail and painting and real freedom for the artist to really work with the material that they can feel directly with brushes. So I'll get that going for a few more seconds. And the next stage is I'm going to draw your attentions to the level of subdivisions. In a second, there we go. So if you look at this pull down, I don't know if it's really readable for where you are, but you can see that this mesh has been subdivided 6 times for a total of 4.5 million quads. So we're dealing literally with 4.5 million faces on this object. So once again, this is way too big to handle for rendering or animated or in any interactive ways. We're going to find ways to render this using PTex in Renderman in a way that looks almost as identical as possible to what you just saw over here. So I'm going to start over here in Maya. I'm loading an FBX version of the Toad King low resolution mesh, and you can see it here. It's only got 1,000 faces. This is a low resolution mesh. So as you can see, this is obviously very easily usable for us because it's very low resolution. So we can pose it, we can interact with it. I'm deleting over here a couple of shaders that came from the FBX files because that's going to confuse the next tool I'm using over here, which is Renderman Studio. So I don't know if you're familiar, but Pixar sells the Renderman software. And for users to interact with Renderman, we have a plugin in Maya that's called Renderman Studio that converts all the Maya data into something Renderman can use to produce a picture. So this over here is the user interface that allows us to control the image attributes of the render. So I'm just basically changing over here the file format, the image resolution, and finally also the gamma, because we're living in an sRGB color space. So I'm just applying a 2.2 gamma over here. Here we go. And we're almost ready to go. The next stage after that is I'm using a feature that's been available since Renderman Studio 2.0. So it's pretty old by now. It's old school. It's 2 years old. And it's an environment sphere. So this will allow me to use an image, a high dynamic range environment image to do image-based lighting in my shot. So as you'll see in a couple of seconds here, I'm going to load an EXR, OpenEXR, high dynamic range environment map. And because I'm really not a good lighter, I'm using this, an image-based lighting solution, to light the Toad King. And here I'm just adjusting a couple of parameters. And also because I did happen to notice when I looked at the image that the sun was a little bit on the weak side, I decided to add a directional light just to give my lighting a little bit more kick. Once again, I'm really not an artist. As you can see, my lighting setup, I'm not cheating, is very, very, very simple. I'm not interested in really making the image look pretty just yet. I just want a bare-bone lighting solution that is close to something physically believable. And I should probably give a credit to whoever produced that environment map. I'm trying to remember who it was. I'm sorry, I'm failing right this second. But if you're really interested, I can probably tell you which site I found it on the internet someday. Adjusting a bit my parameters on the directional light, and I'm pretty much ready to go. I'm going to shade the creature now. So this here is Slim. Slim is, once again, a user interface that Pixar makes so that users can develop shaders using the Renderman shading language, but in an artistic way. It's very similar in functioning in how Hypershade works in Maya. So if you use Hypershade to shade in Maya, this is the same idea. The only difference is it leverages all the power of Renderman in terms of rendering. So I'm getting started over here, and I'm creating shaders. And the reason I'm showing you all these steps is I really want to prove I have nothing in my hands, nothing in my pockets. I'm not pulling tricks outside of your knowledge. I'm just creating a very basic shader here, which has a diffuse component. And as you'll see in a second, I'm actually even turning off the specular component. So I'm just using a basic Lambertian white shader. It's as dull and boring as it gets. Now make sure that I attach the shaders to the geometry after cleaning up a couple of names. Once again, I did a capture a bit in a hurry. I should probably have edited these bits out. So we're assigning the shaders to the geometry. So right click, attach. There we go, and because I'm usually paranoid, I make sure that it's been attached, so I reselect the geometry. But we're now ready to do a test render. So this is the Toad King, all naked. We haven't done anything with it yet, it's just in the basic lighting environment. Notice how quickly this stuff renders, by the way. Couple of seconds, entirely image-based lighting, it's global illumination, with a very simple setup. This is our limit surface, now we're going to start building on top. So I'm going to interrupt here the video once again. And what you're seeing here is one of our proprietary tools that we have at Pixar. So once I was developing all these algorithms and solutions, we didn't have yet support for PTex in Mudbox. And like I was explaining earlier, PTex, the indexing of subdivisions works really easily if you've got quads only. But unfortunately for us, our geometry most of the time has quads and triangles and pentagons and other kinds of faces in the mix. So I had to come up with a solution that sort of it allows still to find that texture indexing automatically, but could work with non-quads. And believe you me, it's actually not as easy as it looks like. So to do this, I actually figured out a really brute force way, and this tool over here that you're seeing here is probably just a transitional tool until we can move on to the fully integrated Mudbox solution. But I'm still going to show you this because it's a couple of interesting aspects. This tool requires 3 FBX files that we export directly out of Mudbox. The first one is the low resolution, it's the 1000 faces of the Toad King. There is no sculpting, there is nothing, this is the bare bones models you just saw in Maya. The next FBX file is what I need for the limit surface. So that's the smooth Toad King minus all the sculpting that's been done to it. And as you can see, my little tool over here shows you a little outliner that shows exactly that it's fine correspondence but in all these meshes, so it's happy and it can move on. The final mesh over here is the last one that I'm loading. Actually, I've got a little bit ahead of myself, is the sculpted mesh. Once we have all these free meshes, you can see over here I've got all my free little green lights rows, everybody is happy, I can move on. I'm now giving a directory where I'm going to save my PTex displacement files. So that's it, I'm selecting a directory, and once I'm ready, I click the extract button, the tool's going away, it's thinking about it, and it's trying to find out the difference between the limit surface and the sculpting that we've done in Mudbox. And if you look over here down in the output over here, if you've got eagle eyes, because I don't think it's really readable, one of the outputs over here also is the displacement bound. So it tells us how far the sculpting has gone from the original surface, which helps speeding up the renders later. The next step over here is the proofing. So in other words, you've rendered your texture map, you want to take a look at it. So I'm using a tool over here that comes with Renderman. It's called PTex View. If you buy Renderman, it's coming with a toolbox. You've got it. So if you have PTex files, you can inspect them with this little OpenGL tool. And this is my displacement map. So unlike regular displacement map, as you can see, this texture is really three-dimensional. That's a PTex file. That's the new thing about it. There is no unwrapping of UVs. It just knows where this stuff is in space. It knows which texel is near which other texel. And you can really see all the high-resolution detail I'm getting into the displacement map. Selecting here individual faces. If you can read it at the very top, I don't think it's quite readable. It's 64 by 64 texels of resolution on each face of the model. And these are vectors, they're three-dimensional vectors. This is what we're going to use to affect our displacement. So I'm going to move on to the next stage. We're back in Maya. And the next stage over here, I'm going to show you that because currently, once again, this is beta software. The current version of Renderman Studio does not actually have the knowledge of PTex for displacement. So I had to write very quickly, in a little text editor over here, a special custom node for Slim that would do the work. But in fact, most of this text is completely useless. The only shading language code is the green portion that you see at the very bottom. That's what explains Renderman what to do with this PTex displacement file. So I'm going back to my old shader. I'm loading my custom template over here. So I'm basically typing slim, read slim file, name of the file I just saved. It's very simple. And I'm going in, I'm creating now the new custom node that I just wrote in my text editor. So this now is my PTex displacement template node. And I'm connecting this to the displacement slot into my shader. As you can see, there's very few frills. There's not a whole lot of user interface controls because I just wrote this from scratch in 5 minutes. I'm going to go and browse my PTex displacement map that I just generated with my custom tool earlier. And lo and behold, once I've set up my displacement bound to optimize the render speed, you'll see that if I render my quick shadeable, come on. Yeah, I'm a slow poke on occasions. If you render your little swatch over here, you'll see that the displacement's been applied, the sphere's already been displaced. Not very indicative of the model, but that's what it looks like. So I'm now ready. There's one more stage. I mentioned earlier that PTex requires face indexing. What I'm showing you over here is the current way of doing this, but by the time this software ships, there should be one single button push that should make this easier. So we're using a little filter over here that's called a Ref filter. And once again, this is something that ships with Renderman. You don't have to write any software for this. This is all part of the toolkit. It's temporary because we're sort of bridging gaps until all the solutions have more user-friendly interfaces on top of them. But I'm just basically pointing to that particular filter. That's it. That's all I have to do. Now Renderman knows how to index every face on the model to match the indexing on the texture. And I'm ready. I'm going to render. And you'll see my Toad King now take on the shape that was originally sculpted in Mudbox. Notice once again the render speed. This is real time. I'm not cheating. I'm not speeding up the video in any way. This is a render on my local old workstation that's 4 years old on 8 cores. That's it. And here I've got a turntable, so you can actually see the interaction with image-based lighting. This is what we sculpted, at least bare bones, but we already have the shape with all the details down to the last brush stroke that was sculpted originally in the model. So far, so good. Next stage. Now we want color. So same thing here. Fortunately for me over here, I was lucky enough to have an actual PTex node that can read colors out of the box, so I didn't have to write my own custom node. And I'm just creating that node here. I'm just about to parent it properly to the shaders. I'm parenting it to the diffuse color over here. Just like Hypershade, we connect node. We keep on adding components to our shaders. Same thing, I'm going to browse to the color PTex files for the model. So I'm picking the body because I'm currently shading the body over here. Once again, I'm getting a swatch that sort of is indicative but not very useful. But we're already ready again to do a quick test render. And you'll see that now our Toad King over here is going to have all the colors that were painted in Mudbox by the artist. So once again, I'm not cheating. This is really my old pokey workstation with 8 cores. Rendering on all 8 cores, obviously, but this is the actual real true render speed. I'm not cheating here. And hopefully this will finish in a second. There we go. And we have the basis. So now I'm going to go back to my tool, and I'm going to show you one more of the tricks that we have up our sleeves. So you've seen this before. One of the next great advantage when you've got such amounts of detail on your model is that you want an ambient occlusion pass that really captures that richness of detail. Mudbox actually comes with a solution that calculates ambient occlusion, and we do like it, but unfortunately it is ray traced, which means it suffers from one flaw that we can't unfortunately work with very easily, and that is create noise. Instead, Renderman has a method that's point-based, that doesn't ray trace to calculate ambient occlusion. And what I did over here actually is integrate some of the code inside of Renderman into this tool so we can do this automatically. On the other hand, if you have RMS, you could, assuming that you can write a little bit of software that handles point clouds, you could write a tool that does pretty much the same thing. So I'm going to show you once again. I'm loading my free FBX files, the same as before. No cheats, no changes. Low resolution, smooth high level, or smooth refined, and sculpted refined. Same thing, I'm picking a directory for the displacement, but I'm also creating a new directory now for the ambient occlusion. And now I'm turning on the actual ambient occlusion extraction settings, tuning a little bit the quality settings over here. And I'm going to push the extract button in a second. Here, on the other hand, I am actually cheating a little bit. This process took a little over 5 minutes. I didn't want everybody to sit here for 5 minutes because you would all be bored. So instead, I'm showing you a little bit over here some of the output very quickly. One of the things you want to know is this stuff is multi-threaded, and it renders on as many cores as you've got, so it scales really, really well, and it is really fast. Once you're done with this, however, once again, I'm going to bring my little inspection tool over here. And here is the PTex surface. And you can once again see the whole details that we get in the ambient occlusion map. So I'm going to try to rotate over here through this and try to give you an idea of the amount of detail that we capture in this map. And this is the amount of detail that is now becoming our ambient occlusion pass. This is once again inspecting individual faces. You can see every scale, every detail in the model has been captured in the ambient occlusion pass. Once again, there's 1,070 of these faces, so that's why this stuff can rotate so quickly and so easily. The other thing that you probably want to know is how big is this file? Well, this file is about 10 megabytes on disk. This is once again the turntable where I have now added the ambient occlusion. So you can see that we're now having a Toad King. That's not looking very interesting, and we're emphasizing all the sculpting detail with a beautiful ambient occlusion pass. And I've used another image-based lighting environment just to show a bit the difference, and once again situate the creature and the sculpture in an environment that shows off really the amount of detail and the richness of the sculpture. So this is no ambient occlusion, the PTex baked ambient occlusion. And just for comparison over here, I actually did a ray traced pass where, in other words, calculating ambient occlusion is done through ray tracing in Renderman, and we ray traced against the display surface, which is massively expensive, just to compare the difference between the baked occlusion. So there is a bit of difference, but it's barely perceptible. I mean, you really have to pay attention to notice it, and you have to know where to look for it too. So now at this point, I could go on and show you more and more how I'm setting this up. Instead, I'm going to pull a little bit of a Julia Childs over here and get my fully prepared dish from a scene I've actually saved, and I spent a bit more time adjusting the coefficients. I just want to show you I'm not cheating. I added a shadow map, a deep shadow map actually, onto the model. So I'm showing you over here the settings, so 1K shadow map, I believe. I tweaked a bit the shaders, so I'm going to show you very quickly the shading networks, just to show you I'm not doing anything really fantastic. It's just barely more complicated. I'm using the ambient occlusion pass over here to break up the specular reflection. I'm using it to break up the specular highlights too. And I'm using the ambient occlusion pass once again to modulate the diffuse. So I'm going to modulate the colors, specularity, and reflections with the PTex ambient occlusion. So that's pretty much what this network over here does. So you see a few nodes that remap values, multiply, divide a few things, adjust coefficients. I really tweaked this in a matter of hours. This is the PTex ambient occlusion. There's a little trick actually over here. I'm using only one node, but there's a little macro in Slim that you can use that's going to replace automatically the name of each geometric primitive. So if you got a character that's made of 50 primitives, it very quickly will find automatically which texture to apply to each primitive. This is the shader that's applied on the eye. It's identical to the other one, minus the displacement, because there's no displacement on the eyes. And really, that's pretty much it. I'm not cheating. I'm not inventing any really complicated shading. I will, however, in a second, push the render button again so you can see what this looks like with everything put together, and a little bit of care being paid to all the settings, a bit of attention to make this look a little better. So I'm rendering here the shadow map. Once again, I'm not cheating. It's rendering on my old machine. I should have probably also mentioned that the files were not even on my local hard drive, so there is network latency in the render time. But it's still pretty damn fast. And this is the final image I'm getting of the Toad King with everything turned on. So reflections, ambient occlusion, colors, all the color layers actually, because there were more layers than I was originally showing. But this is how this guy looks like, rendered in Renderman, out of the beautiful sculpting that started in Mudbox. So really what we're trying to go for over here, I'm going to coin probably a new term over here, with the word, what you sculpt is what you render. We want to get as close as possible to this. So here, once again, showing and proving 8 cores. This is the render speed. This is how beautiful this looks like with however much detail as you sculpted originally in the model. And here's a quick turntable of the final product so you can actually see the whole thing in action. That was, again, set up in a matter of hours based on the original sculpture done in Mudbox. And as far as I can tell, every single scale, every single detail on his back and around his mouth and on his head, everything is here. All the bone protrusion on his back. It's all there in glorious detail. Everything is very accurate and very close to the original. All right, so I was showing you some of the proprietary workflows we have at Pixar, but because we worked very actively with Mudbox, in fact, this is probably one of the best examples of cooperation that Pixar has had with Autodesk so far to date, and we've worked many hours with Bill Dyack and some of the other engineers to get this working. We have shared some of the technology back, and what I'm about to show you here is the beta of Mudbox, and you will see that it already supports PTex extraction out of the box, literally. So here we now have a vector displacement extraction capability out of Mudbox. I'm selecting the Toad King at 2 levels, low and high resolution, and if you go down over here, you will see that now we have a new file format over here, which is PTex 32-bit vector displacement files that you can extract directly. So I'm giving a file name over here. If you pay attention over here at the very bottom, you now see that you can include the mesh data. So if you use this, you can use PTex View to inspect your textures when you've done them. And you simply press the extract button, and this does exactly the same work as my proprietary tool was doing a few minutes ago, based on FBX files. And of course, the same functionality is also available for paint layers. So if you've been painting your creature, you can right-click on the paint layer, and you can follow the same workflow, which choose as your format of export PTex, and you get a color file, a color PTex file that is your export out of Mudbox. All right, so that's pretty much it for me today. Before I leave you, I just want to give a bunch of thanks for the fantastic team of Autodesk. So Bill Paulson, my manager at Pixar, Bill Dyack here at Autodesk, who's been working sleepless nights and countless hours to help me write plugins for Mudbox first as a sort of proof of concept, and then later on work inside of Mudbox to provide all the support for PTex. Craig Bauer over here is the artist behind the Toad King sculpture, which is phenomenal and very inspiring in many ways. And also Brent Burley at Disney, who's the inventor originally of the PTex file format. So that's it for me today. And I'm going to leave you with some of those turntables again, just for the pleasure of seeing how the sculptures in Mudbox can look like once you render them in Renderman.
Thank you very much. Let's have a hand.